the olden days, life out in the country, or Western media in general, odds are you've probably heard about moonshine. The term moonshine was originally a British saying that had the meaning activity conducted at night, in reference to the shady, unregistered, or otherwise illegal synthesis of alcoholic beverages that resulted from the growth of excise laws there. And as the term slowly made its way into America, the meaning eventually changed into what we now know as whiskey, liquor, or other strong alcoholic drink made and sold illegally. The history of moonshine in America goes all the way back to the 1800s, where grain farmers on the American frontier would distill their crops of wheat, corn, sugar, and other crops into alcoholic beverages, the most common of these being forms of whiskey and liquor, derivatives of grain and fermented fruits. They often came with the risk of carrying deadly byproducts, however, which in deadly quantities could make their drinkers sick or worse. Though present in America since the early 1800s, it didn't take significance until shortly after the Civil War, with growing presence into the Prohibition era of the 1920s. During this time, sale and production of alcohol became increasingly regulated and eventually outright banned, which turned the alcohol market in the United States to a legal means of rum running, bootlegging, and moonshining to make, sell, and consume alcohol. Though the era of Prohibition and the need to make moonshine alcohol illegally has long since passed, its presence can still be seen in today's beverage industry. Mountain Dew, for example, a popular sugary sports drink today, used to be a slang term for a form of moonshine itself. It supposedly began its commercial life as an alcoholic beverage. Many other store-brand alcoholic beverages today can be seen carrying the term moonshine in some form or another, though this is under a legal use of the word, without the risk of carrying deadly side products or illegal forms of production that they did many years ago.
So let's get into the mechanisms behind the creation of moonshine. The main process of how moonshine is made is just the mechanism of turning glucose into ethanol, or in other words, the process of alcohol fermentation. Typically, we start with corn as our starting material for making moonshine, but in reality, we can use any form of glucose. Here we have our Hayworth and Fisher projection of our D-glucose. You could even use toilet paper to make moonshine. Toilet paper consists of mostly cellulose, which is a polysaccharide containing thousands and thousands of glucose molecules. While it's difficult to break down the cellulose into glucose, with the enzyme catalyst, the process is entirely possible. To start the reaction, we add our yeast to our glucose, and that will start what is known as glycolysis. The glucose will split into two pyruvate molecules. Pyruvate is a 3-carbon molecule with a ketone functional group and a carboxylic group, and is a deprotonated carboxylic acid. Additionally, in glycolysis, ADP will turn to ATP, and we will also generate NADH from NAD+. NAD+ is an electron carrier and is reduced in this reaction. We're going to have to skip over the mechanism for glycolysis, as the mechanism is quite long and we don't have quite enough time to cover it. But put simply, we have the formation of our pyruvate. Once we've formed our pyruvate, we will form our acetaldehyde next through a process known as pyruvate decarboxylase. Finally, after the formation of our acetaldehyde, our NADH, which we formed from earlier, will reduce our acetaldehyde into ethanol. Now that we have a better understanding of our overall general reaction, we will get into the arrow pushing mechanism. We will be skipping the arrow pushing mechanism, as I mentioned earlier, for the glycolysis, starting from the formation of our pyruvate. So once we have our pyruvate, and starting from our pyruvate decarboxylase, a molecule known as TPP will help us remove a CO2 group from our pyruvate. We're going to assume neutral conditions and that water will act as a weak acid and weak base in our reaction. Water will act as a weak base here and deprotonate the active part of TPP, and this carbon ion will react with the pyruvate, attacking the carbonyl carbon. Following this nucleophilic attack will result in the tetrahedral intermediate of TPP. This tetrahedral TPP intermediate will grab a hydrogen from water, creating a better leaving group for our CO2. Our CO2 will then leave, resulting in the product found on the very right. Continuing from the last step, we see that we have a resonance stabilized carbanion. Water will then act as a weak acid, donating a hydrogen to this resonance stabilized carbanion. Finally, water will take a hydrogen from the OH group, form a double bond, and break the bond between the acetaldehyde, the product we will focus on, as well as reforming TPP. This marks the end of our process of our pyruvate decarboxylase. Now that we have our acetaldehyde, we will begin our final step of our alcohol dehydrogenase, which will turn our acetaldehyde into our ethanol. NADH is a very powerful reducing agent and will reduce our acetaldehyde into our ethanol. We will get a hydride that will attack the carbon on the carbonyl group and form a tetrahedral intermediate. This intermediate will grab a hydrogen from water and result in our final product of ethanol, as well as the reformation of NAD+, which overall in our reaction acted as a catalyst. Now that we understand the mechanism of alcohol fermentation, we'll be moving on to talking about distillation of moonshine.
The entire process of making moonshine is actually quite simple. However, to extract the ethanol in the right molarities is much harder to master. To extract ethanol from the mash of fermented liquid, the entire process undergoes a distillation. This distillation can be done using the microscale techniques learned through organic chemistry lab. In microscale techniques, connect a round bottom flask that has the mash to a fractional column, and then connect the fractional column to a condensing column that leads to the containers. The mash undergoes a reflux from around 79 to 91 degrees Celsius. The reason for this is because the desired ethanol starts to boil in a mixture in this temperature range. This microscale setup is not dissimilar to an industry scale production, as the mash is set to vaporize and then is piped to a condenser where the products can be extracted. While ethanol in a mix does vaporize at this temperature range, so does the multitude of other organic substances still trapped in the mash. Because of this, distillation products are often taken in multiple separate cuts. The first cut, known as the foreshots, contain all of the methanol that has come from the fermented mixture because it vaporizes at lower temperatures. When the mash reaches a temperature range of around 79 to 82 degrees Celsius, this is when the foreshot container is thrown away, since methanol is a deadly poison for humans. The second cut is called the heads and is around 20 to 30% of the total collected product. This is where the alcohol is starting to distill, but there are other organic substances like ethyl acetate, acetaldehyde, and acetone still contained. These cuts are mostly used to be redistilled later. The next set of cuts is called the hearts and is the most desirable and flavorful part of the distillation. The hearts are collected at an 82 to 90 degrees Celsius range and make up around 30 to 40% of the total alcohol collected. This is where distiller's mettle comes into play, as it takes skill to recognize the beginning and the end of the hearts cut. After the hearts cut comes the tails, which vaporize past 96 degrees Celsius. This contains heavy molecular mass organic compounds like propanol, butanol, and amyl alcohols. The tails are not good tasting, losing sweetness and taste thin, as they contain much more water than the previous other cuts.
The process of making various kinds of moonshine might be similar, but it is those starting materials that lead to each type of moonshine's distinct flavor. There are certain organic compounds in each of these various types of moonshine that can lead to their distinct properties. For wine, grape skin contains anthocyanins. When the skin is crushed, they react with other chemicals in the grape to produce various pigments. Grape seeds contain flavan-3-ol, which contributes to their bitterness. In moonshine mash, the amount of seeds can be altered to adjust the bitterness of the alcohol. Lastly, grapes contain tannins, which produce the dry feeling in your mouth that you get after drinking it. Whiskey moonshine has a tendency to include substances called whiskey lactones. What is unique about these is that the cis and trans isomers of these whiskey lactones, like 3-methyl-4-octanalide, which are found in the oak barrel, can lead to various flavorings. The trans isomer leads to a woody coconut flavor, whereas the cis isomer leads to a strong, spicy coconut flavor. Phenolic compounds such as eugenol, found in whiskey moonshine, contributes to the smoky flavor usually seen in certain types of whiskey moonshine. Sometimes a burnt or rubbery flavor can be tasted in whiskey moonshine, and this is a result of sulfur compounds such as 2-methyl-3-methyl-disulfanyl-furan. Cider, which is a common moonshine made from apples, has a distinguished taste due to the components used while making it. Apples contain malic acid, a dicarboxylic acid, which can be converted into lactic acid during the fermentation process. This process leads to the reduction in acidity and helps round out the flavor. Each type of moonshine has a distinct smell, and for ciders, they are due to dioxanes. In cider, 2-methyl-4-pentyl-1,3-dioxane is the most common active odor compound, which gives the cider its unique smell. In moonshine, sugars are almost all fermented, and in order to bring back some of the sweetness, artificial sweeteners such as sucralose are added back. If glucose is added back to the alcohol, the fermentation process would start again, and that is why artificial sweeteners are used instead.
Thank you for watching. If you liked the video, comment down below on what we should try and research next, or you can hit the like and subscribe button.